this is the real Tom Rose, and this question is testing whether you can build functions out of charts when you're dealing with sines and cosines. So you need to know what a sine and cosine look like, and you're going to need to know how to translate and scale these as needed. So the first thing to know is what a sine and cosine look like in general, and they both look roughly like this. It's kind of a snaky thing along the horizontal axis, right? So this looks sine and cosine-ish, but what we need to do is figure out how big it is and how to scale it and whether it's sine or cosine. So one way that you can spot these is sine always starts on 0 and cosine starts on 1. Or sorry, sine starts at the origin, 0. Cosine starts, at its peak, I should say. The cosine by itself would have started at 1. So let's say that we know this is a cosine now because it starts at its peak at x equals 0. A cosine would start at 1, and a cosine would have a period of 2 pi. So a cosine would look like this, roughly. Right, so over 2 pi, it would do a single full squiggle and be back up at its peak. Now what we want to do is we want to make sure that this is, so the orange, the one that I just drew, that's cosine of x. Now what we want to make sure is, well, first of all, we want it to be 3 times as big because we want the peak to not be at 1, but to be at 3. So let's do the following. So in blue, we'll do 3 cosine of x, which will have the same period, but now it will be 3 times bigger. Right, so that's what happens when you multiply by 3. Just like however far you are from the x-axis, is you're always 3 times further if you multiply by 3. It's as simple as that. But we need to fix the period. So what we can do is, first of all, inspect the period. How far off from the regular period are we? So the regular period is it takes 2 pi to do a full cycle. In this particular chart, we actually have, count the cycles. We have 1 peak, 2 peaks. We have exactly 2 peaks in the time we should have 1 peak. So this is going, you might say, twice as fast, or the period is half as long. So the way that you double the period, the way that you have the period, or double the rate of peaks, is by multiplying the variable inside by 2. So let's say in purple, we're going to multiply 3 cosine of 2x. So now if this cosine hits its peak at 0 and 2 pi, when will this interior thing, when will this evaluate, just the inside part, when will that evaluate to 2 pi? Well, it'll evaluate to 2 pi when x is at pi. So when x is at pi, our function thinks we're at 2 pi. So it makes sense that you'd have a peak there, right? So by multiplying that x by 2, we've essentially made this thing go twice as fast. So now, if you do that, you can see that we're, boom, right on top of this thing, of the black line, which means we've hit it. So the answer is 3 cos 2x, which is the third answer choice.